Are we really here? As in, are we really here right now at this very moment? Welcome to Seashell Space, where today we're diving into the multiverse theory. What is it? Why do physicists think it might be real? And what does it mean for us? This is one of those topics that's so big and so bizarre, it almost defies explanation. But we'll try anyway. And if that doesn't work, maybe you can experience it. Here goes. There's a haunting echo in the vast expanse of space. A low rumble that seems to vibrate at the very core of existence. As we gaze up at the night sky, we wonder if this is just the soundtrack to our world. Or if it's a whisper from distant universes beyond our own. What if our universe isn't unique? What if beyond the stars we see lies an endless ocean of other universes? This is the mind-bending possibility of the multiverse. Now, before we go any further, let's talk about infinity, because the multiverse has a lot of it. Our universe contains everything we know of: stars, planets, galaxies, black holes, dark matter, even hypothetical particles called gravitons that might be responsible for gravity. All this stuff takes up space and time, but those things themselves are made of even smaller pieces. Particles, and we can go smaller still. We know that all matter is made of atoms. Then we find protons and neutrons, which are made of quarks. Keep going, and you end up with strings vibrating in many dimensions. The idea that all matter is really tiny vibrating strings is called string theory. But we won't get too much into that here. Just take away that we keep finding levels within levels within levels when we explore the tiniest parts of the universe. And string theory predicts that there should be more levels, additional spatial dimensions curled up so small we can't see them. These curled up dimensions are thought to be at the center of some models of the multiverse. More on that later. So let's get back to the idea of infinity. In most people's minds, infinity means never-ending numbers. 1, 2, 3, etc. That never stops. But infinity can also describe shapes. Consider a flat sheet of paper. There are many lines you can draw on it. Draw a circle and it's infinite because no matter where you start and where you end, you're always back where you began. Infinity can also describe locations. Imagine you're a flat creature living on a sheet of paper. You can only move left and right, forward and backwards. For you, that's all of space. But you probably notice there's more to the world than a single sheet of paper. Hence, we can conclude your world is not all of space. Now imagine that every direction you can move is actually infinite. Your universe is one among countless others in a vast, boundless realm. No matter which way you travel, you'll always find another universe like it. This is the concept of a two-dimensional universe. If we add another dimension, we come to the universe we live in. This is a three-dimensional universe. In this case, a bubble inside an infinite foam of other universes. In fact, there are many ways to model the multiverse. The bubble multiverse is one of the more popular ones. According to this idea, there are countless expanding bubbles of space. Each bubble becomes its own self-contained cosmos. Some bubbles may have different laws of physics. They might have different constants like the strength of gravity or electromagnetic force. Others might look like ours. In some, the speed of light might be faster or slower. In others, there might be fewer or more dimensions. In some, the chemistry might be different, and life as we know it couldn't exist. In others, life might not only exist, but it might thrive. In some, the universe might collapse in on itself. In others, it might expand forever. There could be bubbles where the fundamental forces of nature combine in different ways. In others, they might not combine at all. Some bubbles may contain other universes inside them. Others might have their own antimatter counterpart. We don't know. This is science fiction, not science scary yet. Let's look at a few more models of the multiverse. First, there is the many worlds interpretation of quantum mechanics. According to this theory, every time a quantum event is about to happen, the universe splits into many parallel universes. Every possible outcome of the event happens in one of the new universes. So, if you have a coin, there's a universe where heads wins and a universe where tails wins. But if you have Schrodinger's cat, there's a universe where it's dead and a universe where it's alive. Every time you make a decision, the universe splits. Every time a quantum particle makes a decision, the universe splits. The number of universes increases exponentially until you have more parallel universes than stars in the night sky. Eventually, every possible variation of reality will occur in one of these new universes. One theory says all of this happens during the quantum jump, a term coined by physicist John Archibald Wheeler. Another theory attributes it to decoherence. This is when quantum systems become entangled with the environment around them. However, both theories end up with the same result: a huge number of parallel universes, each containing slightly different versions of you. Finally, there's the brain-world model. This model proposes that our universe is like a sheet floating in higher dimensions. These extra dimensions are again curled up so small we can't see them. The brain-world model suggests that our universe is just one of many in this higher dimensional space. Other universes float past us unseen. So, that's the multiverse. We know it sounds weird, but bear in mind, so did Einstein's theories of special and general relativity. And they changed the world. At least, they changed our understanding of the world. Could there be evidence for the multiverse? Sure. Any model of the multiverse that scientists develop must make testable predictions. For example, there should be imprints of the collisions between universes. Scars in the cosmic microwave background radiation are hints from particle physics. So far, though, the evidence is pretty thin. But remember, all of these models assume the existence of other universes, and we can't observe them directly. Making direct observations of other universes would be impossible. So physicists have been looking for these indirect clues. For example, maybe the fact that our universe is fine-tuned for life is evidence for the multiverse. Our universe has the exact right conditions for life as we know it. Stars and planets form under just the right conditions. The chemical activity necessary for life happens at just the right pace. And we haven't found aliens yet. Some physicists think this fine-tuning is a coincidence. But others argue that if there are an infinite number of universes, then the conditions in some of them are bound to be suitable for life. If you assume that there are other universes, then the fact that we exist becomes unsurprising. We aren't sure how many dimensions we live in. If you want to learn more about dimensions, check out our video on the subject. But we know that our universe expands. It's also curved. So there's that. In the end, the multiverse is an idea we can't prove or disprove. It's more philosophy than physics. It's a way of thinking about the nature of reality itself. It's a way of asking what the rules of nature are and why we're here. It's a way of looking at the vast expanse of space and asking if there's more to it than meets the eye. And if you like SCI Show Space, you're probably the kind of person who likes to ask what's out there. So we've got a question for you. Have you ever watched one of our videos and thought, wow, I wish I could share this with my friends? Well, now you can. Just hit that subscribe button. Then whenever we release a new video, it'll show up in your feed and you can share it with your friends. And thank you for being here.